So good morning students. This is Addagatla Nagaraju, working as lecturer in electrical and electronics engineering, Government Polytechnic, Station Kanpur. So today we are going to start AC machine subject, DEEE fourth semester's AC machines subject we will start. So in AC machines, single phase transformers chapter we will start today. Single phase transformer. So in that introduction, a working principle of single phase transformer and a classification of transformers we will cover. So single phase transformers. So on completion of this period, you would able to know on completion of this period, you would able to know importance of a transformer, features of transformer, working principle of a transformer, importance, features, working principle, and also classification of transformers based on various factors such as number of phases, construction, and function, number of winding, type of cooling. Based on location, based on rating, based on frequency. So transformers classification based on various factors such as number of phases, construction, function, number of winding, type of cooling, based on location, based on rating, based on frequency. See, overview of electric power system. Here, power generation. So power generation may be idle, may be different types. So here I am showing idle power plant, thermal power plants also present. So power generation in the range of 11 kilowatts and 33 kilowatts voltage. This voltage is step up and this higher voltage transmit the power. So these are the transmission lines, and this high voltage step down to the distribution transformers, and this distribution transformers transfer 33 kV around. Now this 33 kV is step down to 11 kV and 440 volts, single phase 230 volts. Here use step up transformer, here step down transformer. Okay. The here also step down pole mounted transformers. This is also step down transformers. So in transmission and distribution, we use transformers. It is a transformer, it is also one transformer. Transformer is 120 years old. First transformer of the world, 60 watts, 4.3 to 46.5 volts, 18 Hz, single phase shell type, dry type transformer. So it is patented in 1885 by three engineers. So these three engineers' names combined and the name implied the transformer. Transformer. So in 1831, Faraday law of electromagnetic induction discovered. Whenever conductor cuts the magnetic field, EMF induced. Faraday's law of electromagnetic induction. In 1864, Maxwell's equation for mathematical model of electromagnetic apparatus formulated. 1885, first real transformer patent. 1893, first three-phase transformer was used in Elson 99.6 kilowatts transmission system in Sweden. And in 1900, oil immersed transformer was born. So electrical power is transformed to output. Transformer is a stationary electric machine which transfers electrical energy from one circuit to another circuit with the same frequency but with different voltages and currents. A motor converts electrical power to mechanical power. Generator converts mechanical power to electric power. Coming to the transformer, unlike in rotating machines, there is no electrical to mechanical energy conversion. A transformer is a static device and all currents and voltages are AC. The transformer of energy takes place through the magnetic field. So, coming to definition, transformer is a static device which transfers electrical energy from one electrical circuit to another electrical circuit without change of frequency through a common magnetic flux. Transformer is a static AC machine which transfers electrical energy from one circuit to another circuit without change of frequency through a common magnetic field. Electrical energy generated at places where it is easier to get water head and coal for hydro and thermal power stations respectively. Electrical energy generated is to be transmitted to considerable distances for use in towns, cities, and villages. Transmission of electrical energy at high voltage is economical. Electrical machines are required for stepping up the voltage at generating stations. Electrical machines are required for stepping down the voltage at places where it is to be using. Electrical machines are used for the purpose is known as transformer. Electrical machines are required for stepping up the voltage at generating station and required for stepping down the voltage at places where it is utilized, and these machines are known as transformers. So no electrical connection is present between the two windings. So two windings, primary winding and secondary winding, both are electrically isolated but magnetically coupled. Electrically isolated but magnetically coupled. So no electrical connection is present between the two windings. Magnetic linkage exists between the two windings. The magnetic linkage is provided through a path of low reluctance. A transformer basically consists of two windings which are wound on a soft iron or silicon core. Transformer basically consists of two windings which are wound on a soft iron or silicon steel core. The winding which is connected to the supply mains is known as primary winding. The winding which is connected to the load is known as secondary winding. The transformer works on the principle of mutual inductance between magnetically coupled coils. It is based on Faraday's law of electromagnetic induction. So here two circuits, primary circuit and the secondary circuit, both are electrically isolated but magnetically coupled. So flux generated in the primary winding is linked with the secondary winding. So this is called a mutual induction between two magnetically coupled coils. And based on Faraday's law of electromagnetic induction, EMF is induced in the secondary circuit. When primary winding connected to AC supply mains, a current flows through it. This current produces an alternating flux in the core. These flux links with primary winding and produces self-induced EMF in the primary winding, which opposes the applied voltage. When primary winding connected to AC supply means a current goes through it. This current produces an alternating flux in the core. This flux links with the primary winding and produces self-induced EMF in the primary winding, which opposes the applied voltage. This flux passes through the core and links with the secondary winding to induce an EMF called mutually induced EMF in the secondary winding. This flux passes through the core and links the secondary winding to induce an EMF called mutually induced EMF in the secondary winding. The frequency of the EMF induced in the secondary is same as that of the flux or that of the supply voltage. This flux passes through the core, links with the secondary winding to induce an EMF called mutually induced EMF in the secondary winding. The frequency of the EMF induced in the secondary is same as that of the flux or that of the supply voltage. The induced EMF in the secondary winding will be able to circulate the current in the external load connected to it. The induced EMF in the secondary winding will be able to circulate the current in the external load connected to it. Energy is transferred from primary winding to secondary winding by electromagnetic induction principle without change of frequency. The induced EMF in the secondary winding will be able to circulate the current in the external load connected to it. Energy is transferred from primary winding to secondary winding by electromagnetic induction principle without change of frequency. Without change of frequency. When the transformer raises the voltage, it is called a step-up transformer. In step-up transformer, the output voltage is higher than input voltage. In step-up transformer, secondary winding turns are more than the primary winding turns. When the transformer reduces the voltage, it is called step-down transformer. In step-down transformer, the output voltage is less than input voltage. In step-down transformer, secondary winding turns are less than the primary winding turns. Coming to the classification of transformer, transformers are classified based upon the number of poles. Single-phase transformers, polyphase transformers, polyphase two-phase transformers, three-phase transformers, single-phase, two-phase and three-phase transformers. Based on the construction, they are core type and shell type. This is the core type transformer. Here, LT winding is here. HT winding is above the LT winding. Here, this is a shell shaped and the winding is wound on the middle limb only. Here, the primary and secondary are wound on the outer limbs, but here only middle limb. LT winding, HT winding. Between the two winding insulation is provided. This is the shell type transformer, and this is the berry type transformer. Here is the only one shell. Here number of shells are more. This is called berry type transformer. Berry type transformer. Coming to the based on function, power transformer user per step up and user per step down the voltage, and a distribution transformers are always step down transformers. Power transformers are step up at the generating station, step downs at the distribution substations. And the distribution transformers are always step down transformers. Based on the function, they are classified as instrument transformers. There are current transformers and potential transformers. Current transformer is measure the used to measure the current. Potential transformers are used to measure the voltage. And welding transformer is a special transformer's output is the high current low voltage type. Step down transformers are welding transformers, but they are high frequency, high current, low voltage transformers. And based on number of windings, their primary and secondary windings in a single winding, then it is called auto transformer. Primary winding is separate and secondary winding is separate. Then it is called two-winding transformer. Single winding transformer, that is called auto transformer. Multi-winding transformer. And based on the cooling, if you provide a natural cooling in the transformer, that is called air-cooled transformers. Air-cooled may be natural air-cooled and forced air-cooled transformers. Induced air-cooled transformers. Naturally air circulates, then it is called a natural cooled transformer. Forceful draft. Forced draft is provided, then it is called forced air-cooled transformer. Induced draft is provided, then it is called induced air-cooled transformers. And type of cooling, air cooling, and next oil cooled transformers. Here an insulating oil is provided for cooling. Oil filled natural or self cooled transformers. These oil may be natural or self cooled transformers. And oil filled forced air cooled transformer. This oil is cooled with a fan, that is called forced air cooled oil filled forced air cooled transformers. and oil-filled forced water-cooled transformer. Here, the oil pipes are cooled with the water. These are called oil-filled forced water-cooled transformers. And based on location, they are called indoor and outdoor. Indoor transformers, outdoor transformers. Based on rating, there are low rating transformers and medium rating transformers and also high rating transformers. Low rating transformers, medium rating transformers and also high rating transformers. And based on the frequency, they are called low frequency or power frequency or audio frequency transformers, high frequency transformers, pulse transformers, radio frequency transformers. So, why transformer works on AC only? So, transformer works on electromagnetic induction. Transformer works on the electromagnetic induction and also mutual inductance. What happens when a transformer is connected to DC circuit? So what happens if a transformer is connected to DC supply? The flux produced by DC supply does not vary but remains constant in magnitude. Flux produced by DC supply does not vary. It remains constant in magnitude as flux remains constant, no EMF is induced in the primary and secondary. So no EMF induced in the primary and secondary as there is no self-induced EMF in the primary winding opposes the applied voltage as there is no self-induced EMF in the primary winding opposes the applied voltage, a heavy current will flow through the primary winding. Heavy current will flow through the primary winding and this large current will result in the damage of the winding. Coming to the summary, in this session we have learned about importance of a transformer. So what is the importance of a transformer? Transformer is needed to step up and step down the voltages. What is the need of step up transformer? What is the need of step down transformer? Why? Because the generated EMFs in the power generating stations are 11 kV and 33 kV respectively. So these voltages are directly transmitted to the load centers. Then there is a large voltage drops present and due to the current, large number of I-square or losses are present in the transmission line. Hence, the power is wasted in the transmission, so power is wasted in transmission lines in the form of I square losses. So to reduce the I square losses, we need to reduce the currents with the help of transformer. If the transformer is a constant power device, if we step up the voltage, then automatically step down the current, then the I square losses are decreased. So in transmission lines, I square losses is decreased with the help of high voltage and low currents. That's why transformer is needed. And at the distribution centers, we need to step down the high voltages to low voltage to utilize the power. So in transmission and distribution lines, transformer is very, very important issue. And also for fault isolation. How fault isolation is present at the transformer. So transformer is a magnetically coupled and electrically isolated device. So there is no electrical connection between primary and secondary, only magnetic connection. If the fault is occurred outside the transformer secondary, large currents are present in the secondary, but due to magnetic core saturation, the primary current is not increased in proportional to the secondary. Due to magnetic saturation, large currents are not present in the primary. So it automatically isolates the fault, fault to the healthy network. So that's why transformer is a very, very important equipment in electrical power transmission and distribution and also utilization. And the features of a transformer. Simply transformer construction features. It has only two windings, primary winding and secondary winding. So the flux produced in the primary winding cuts the secondary winding and EMF induced in the secondary winding. Faraday's law of electromagnetic induction and mutual induction principle. So two winding coils are needed, but the primary flux are leakage in nature. So due to arrest the leakage, we need to provide a high permeability core in between primary and secondary. That's why a transformer core is needed to produce low reluctance paths. So two windings and one core is enough. So due to some losses heat is generating, this heat may damage the transformer. So we need a coolant. There may be air cooled or oil cooled adapters. There must be some cooling mechanism also present. These are the minimum requirements of a transformer. Minimum requirements of a transformer. Working principle of a transformer. So when we give the supply to the primary winding, EMF flux is produced in the primary winding. This flux passes through the core and cuts the secondary winding, EMF induced in the secondary winding. Faraday's law of electromagnetic induction and mutual induction principle. Step-up transformer. Step-up transformer increases the voltages and automatically decreases the voltage. Generally, step-up transformers are used in transmission Generating substations. Step-down transformer. Step-down transformer is used to decrease the voltage. Generally, they are used at the receiving end of the transmission lines and also distribution lines. And we have discussed about classification of transformer based on various factors like number of phases. Based on the number of phases, single phase, polyphase, two phase or three phase transformers. Based on the construction, core type, shell type, berry type. Based on the function, step up, step down, number of windings, single winding, multiple windings. Single winding means auto transformer, multiple winding generally two winding transformer. Type of cooling, air cooled, oil cooled, etc. Type of location, indoor and outdoor. Rating, power transformers, distribution, power instrument transformer. CPPTs, frequency, audio frequency and radio frequency. And also we had discussed the working of transformer and AC only. So when we give supply, alternating flux is generated in the primary winding, discard the secondary winding. There is no rotational parts, only statically EMF induced and the relative motion present in the flux itself due to alternating nature. And for the DC, there is no alternating nature, there is no EMF induced in the secondary winding. Due to the low resistance nature of primary winding, high currents produced in the primary results transformer may burn. So coming to the quiz, transformer is which type of electrical machine? Static AC machine, static DC machine, rotating AC machines, rotating DC machine. Transformer is which type of electrical machine? Transformer is a static machine because there is no rotational parts. Transformer is a static machine and also it's a AC machine. It can't run on the AC. Okay, due to alternating nature of the flux EMF induced in the secondary winding. The statically induced EMF, so static AC machine. Transformer is static AC machine. Transformer works on principle of option A, mutual induction between two coils, mutual conduction between two coils, self-induction between two coils, none, none of the above. Transformer works on the principle of mutual induction between two coils. The current passes through the primary winding, produces the flux. This flux links the secondary winding, produces induced EMF in the secondary winding. So statically, it is a mutual induced EMF. So flux produced in one winding cuts the another winding. Mutually induction between two coils. Mutual induction between two coils. Transformer converts electrical energy from one electrical circuit to another electrical circuit without changing option A frequency, option B voltage, option C current, option D none of the above. Transformer converts electrical energy from one electrical circuit to another electrical circuit without change in frequency. So with change in voltage and current, without change in frequency. The winding connected to the supply mains is called option A secondary winding, option B primary winding, option C auxiliary winding, option D none of the above. The winding connected to the mains is called primary winding. The winding is connected to the load is called secondary winding. Less number of turns winding is called step down and more number of turns winding is called step up. So when we give the supply to the winding, that is called primary winding. When we connect it to the load, it is called secondary winding. Supply means it is the primary winding. Primary winding. The winding connected to the load is known as option A secondary winding, option B primary winding, option C tertiary winding, option D none of the above. We already discussed it. The winding connected to the load is known as secondary winding. The winding connected to the supply is called primary winding. In step-up transformer, the secondary winding voltage is option A more than the primary voltage, option B less than the primary voltage, option C equals the primary voltage, option D 0. In step-up transformer, the secondary winding voltage is more than the primary voltage. If it is less than, that is called step-down transformer. Answer: more than the primary voltage. Based on construction, transformers are classified into option A core type, shell type, berry type, option B single phase, three phase, option C either A or B. So based on the construction, they are classified as core type, shell type, berry type. And based on number of phases, they are classified as single phase, three phase. Based on number of phases, transformers are classified into option A core type, option B shell type, option C single phase and polyphase. Based on number of phases, transformers are classified into single phase and polyphase. Polyphase. Distributions of transformers are always step-down transformers. Yes, distribution transformers are always step-down transformers. The transmission transformers are step-up at generating and step-down at loading. But distribution always is a step-down transformers. Step-down transformers. True. Transformers works on AC supply only. True or false? Transformer works on AC supply only. True. Works on AC. It can't work on DC because in DC there is no alternating nature, there is no rotational, so there is no relative motion between flux and conductors, no EMF is induced. Only it works on AC. True. Coming to the frequently asked questions, define transformer. Define transformer. Explain the working principle of transformer. Explain the working principle of transformer. Classify transformers based on various factors. Give reasons for working of transformer on AC supply only. Working on AC supply only. Okay. If you have any doubts, you can mail me at nagaraju.addagatla@gmail.com. You can also contact me through WhatsApp 9866 93 004. Thank you.